Hi guys. Today we're going to be kind of continuing what we did in the previous day's notes. We're going to analyze graphs of quadratic functions, and we're going to talk about all three of those different forms of quadratic functions. So we're going to talk about standard form and vertex form and root form. We're going to do examples of them. We're also going to push your knowledge a little bit, and we're going to include some these different forms. So our essential question today is, how do we identify key features from the three forms of quadratic equations? So if you have the previous day's notes out, the 2-14, the ones where we talked about all the equivalent forms of quadratics, then that's a good idea. If you don't have them out, then you can go ahead and get them out. For each quadratic function today, we're going to find the indicated information. So our first one that we have is y equals 2x squared minus 16x plus 24. So we need to identify the form. And from yesterday's notes, I'm going to go ahead and put that up here. See if you can pick out the form from that little that box. If you thought to yourself that this is standard form, then you're right. This is standard form. The first thing that it asks me for today is the vertex. And if you remember from yesterday, or if you have your notes out, the vertex can be found using a little formula. So the vertex is a point, and the x value can be found by finding negative b over 2a. So let's go ahead and substitute the pieces. B is negative 16, so negative 16 over 2 times a is 2. So this is really 16 divided by 4. And what is that? That's just 4. So there's my x value of the vertex. How do you find the y value? A common theme throughout Algebra 1 and Algebra 2 and into your later math classes is that if you have an equation and an x value, you can substitute it into the equation to get the y value that goes with it. So that's what I'm going to do. I have y equals 2 times x squared. Well, x is 4, so 2 times 4 squared. Not minus 16x, but minus 16 times 4 plus 24. Ooh, all right. PEMDAS tells me to do exponents first, so 4 times itself, 4 squared, is 16, and 16 times 2 is 32. 16 times 4, let's see, 4 times 6 is 24, and if you carry your 2, that's a 6, so 64 plus 24. And if you want to use your Desmos calculator, that's totally fine, but whenever I add all of these together, I'm going to get a nice, pretty negative 8. So there's my vertex. Remember from the vertex, like if you were to plot 4, negative 8, 1, 2, 3, 4, 5, 6, 7, 8, your axis of symmetry would go straight through it, right? Because the axis of symmetry is x equals whatever the x value of the vertex is. So that 4 is what my axis of symmetry goes through, x equals 4. The maximum or minimum value is from the vertex as well. So if I go all the way over, what's that y value? Well, that y value is negative 8. So equals negative 8 is my vertex, is my maximum or minimum value. Now, in order to determine if it's a maximum or a minimum, we need to decide if the graph is opening up or down. And that we can figure out by looking at this number right here. It's positive. So does the graph open up or down? It opens up. So if it opens up, that means that this vertex is at the very bottom of the parabola. So is it a maximum value or a minimum value? It's going to be a minimum value. So you're going to have to circle min for minimum. And then I need to find the roots. If you look at your notes from yesterday, we have a little bit of information about the roots underneath the graph from yesterday. And what we did is we took that equation, 2x squared minus 16x plus 24, and instead of equaling y, we made it equal to 0. And we factored. That's exactly what we did. We factored. So I can take out a GCF of 2. And now how do you factor that trinomial? You want to find your magic numbers. I need two numbers that multiply to be 1 times 12, which is 12. And at the same time, they need to add to be negative 8. 2 and 6 come to mind. But how do we need to change them? They both need to be negative. So here, our factored form is x plus 2, or sorry, x minus 2, because it's a negative 2. Minus 2, and x minus 6. And if I were to set each of my factors equal to 0, 2 equal to 0 doesn't give me any information. But x minus 2 equals 0 tells me that one of the solution is x equals 2. And the other solution is x equals the opposite of this, which is 6. So those are my roots. My roots are x equals 2 and x equals 6. And if I plot them, a 2 and a 3, 4, 5, 6, that certainly looks like it would fit because my vertex is down here. The axis of symmetry is right between the two roots. That looks good. So I need to take a moment to try and find some other x and y values for my graph. And so maybe I'll find the one where x is equal to 1, 2, 3. Maybe I'll find the one here. Maybe I'll find the one here where x is equal to 5. Maybe I'll even find when x is 1, maybe how high I need to go. So those are some other values that I might find. And how do we find them? Well, if you have an x value in an equation, you can substitute it, you can get the y value. So that's what I'm going to go ahead and do. And I can either substitute it into this form or I can substitute it into this form. I think I'm going to stick with this one though. So if I substitute 3, I have 2 times 3 squared minus 16 times 3 plus 24. 3 squared is 9. 2 times 9 is 18. Minus 16 times 3, that's 48, plus 24. Well, 18 minus 48, that's negative 30, plus 24, that's negative 6. 1, 2, 3, 4, 5, 6. That looks good too. Remember that whenever you have a parabola, what you over the other side by counting boxes. So this is one box and one box. So that point right there is 5 comma negative 6. Give you a little bit of time to find the y value when x is 1. So you should have found that the y value that goes along with x equals 1 is y equals 10. So that point shows up here, and I can graph my parabola. Now, Some other things that I need from this equation, and these are new, maybe this isn't new, but these other things are new for what we're doing recently. We've talked about many of them earlier in the year. So if I want to find the y-intercept, well, my x value is 0, so how do I find the y value? That's right, you substitute 0 in place of x. So if 0 is here, 0 squared times 2 is 0. Minus 16 times 0, that's still 0. And then you have plus 24. So 24 is the y value for my y-intercept. My domain, remember, is all of my x values. So tell me about all of the x values for my function. I've got arrows here and here. So what are my x values being used? All of them, right? My parabola is never going to end. It's going to keep going up and out, up and out. So my domain is all real numbers. And my range is all the y values that are greater than this, right? They're all the ones that are above, because this is the minimum value. We said it was a minimum value. So I'm going to take this minimum value of y equals -8, and I'm going to turn it into my range. So my range is all the y values that are what than -8. If -8 is the minimum, then it's all the values that are above, so greater than or equal to -8. Now the only thing that might be a little bit more of a struggle in remembering is the increasing and decreasing intervals. So remember, when we talked about intervals, we're talking about x values. So I'm going to highlight this axis of symmetry here. Because if I read from the left side to the right side, this graph is going down until it hits the vertex, and that's when it changes directions and it starts going up, right? So the decreasing interval, the interval where the graph from left to right is going down, that's all the values that are over here, right? All the x values that are to the left of the axis of symmetry. So everything that is less than this x value, which is 4. So my decreasing interval is all the x values that are less than 4. Well, my increasing interval is after the vertex. So it's all the x values after the vertex. So everything that's over here, all the x values that are greater than 4, that's my increasing interval. So the increasing and decreasing intervals come from the axis of symmetry. Always. We talk about parabolas. They come from the axis of symmetry. So everything to one side will be either increasing and the other side will be decreasing. So let's talk about number 2. Number 2, what form is that? I'm going to give you kind of the cheat sheet from the previous set of notes. What form is that? That's a vertex form. Vertex form. One of the cool things about vertex form is that you can pick out your vertex, h comma k. So y equals a times x minus h squared plus k. Well, h and k is the vertex. So what's the h value? Everything in parentheses is a lie, so it's not -2, it's +2. What's the k value? It doesn't show up, so it has a value of 0. Remember, the axis of symmetry is x equals the x value of the vertex. The maximum or minimum value is y equals the y value of the vertex. Is this graph going to open up or is it going to open down? Since a is positive, it's going to open up. And if it opens up, that means the vertex is all the way down there. It's a minimum. So let's go ahead and graph the vertex. The vertex is at 2, 0. The axis of symmetry goes through x equals 2. My minimum value is y equals 0. That means the rest of my graph is up here. It also means that what? That's my root, right? So my only root is x equals 0. What about the y-intercept? Oh, wait a second. Is the root 0? 0 would be right here, right? Where is this root? This root is at 2. This root is at 2, but there is only one root. Tell me about the y-intercept. The y-intercept has an x value of 0. How do you find the y value? You take 0, you plug it in for x. So let's try that out. $12, right? 12 doesn't appear on our graph. The last one is 10, but if I go up here in 11, 12, there we go. I do kind of need the x value, or at least the point, when x is between these two, right? So where x equals 1, I probably need that. So let's go find that. Let's plug in 1. Minus 2 is negative 1. 1 squared is 1 comma 1, 2. Remember, I can go that doesn't have at the domain of a real number. The range. What was the minimum value? That minimum value was y equals 0, right? So I turned it into my range. My range is all the y values that are less than 0. Above, greater than or equal to. All the y values that are greater than or equal to 0. Let's talk about increasing and decreasing intervals. My axis of symmetry was at x equals 2. Everything on this side is going down, and everything on this side is going up. So my increasing interval is all the x values that are greater than 2, because that's what this graph is doing on that right side. But increasing is all the x values greater than 2. The decreasing is all the x values that are to the left of the axis of symmetry. That's how it's decreasing. So those are the ones that are less than 2. Something that we need to mention, though, is that your increasing and decreasing intervals never include the axis of symmetry x value. Because that point right here, this vertex, it's neither increasing nor decreasing. It's the turning point. So this does not get included. That's why we don't use the less than or equal to and greater than or equal to signs in the increasing and decreasing intervals. On number 3, try to identify the form. So I'll show you the choices from the previous day's notes. There it is. What's the form? That would be root form. So in root form, if it asks us for the vertex first, well, first I need to plot my roots. And the roots are here and here. Remember, it's the opposites though. So my roots are positive 2 and negative 2. So I'm going to go plot those. And from the previous day's notes, it mentions that the vertex, or the axis of symmetry, is halfway between the roots. So if I go halfway between the roots, if I go in 1 and 1, and 1 more and 1 more, well then that's the y-axis right here, right in the middle, right? So that's my axis of symmetry. My axis of symmetry has an x value of 0. So that means my vertex has an x value of 0. And when I have an x value and an equation, I can plug it in and I can find the y value. So here, I have y equals negative 2 times not x minus 2, but 0 minus 2, and not x plus 2, but 0 plus 2. So I have y equals negative 2 times another negative 2 times a positive 2. Negative 2 times negative 2 is 4, and 4 times 2 is 8. So that's my vertex. My vertex is 0, 8. So I'm going to go ahead and graph that. 0, 1, 2, 3, 4, 5, 6, 7, 8. Tell me about the way that this parabola opens. Even if you didn't have a graph, you'd be able to tell that it opens down, right? So that negative means it opens down, but I can also see if the vertex is here and the roots are down here, it's going to have to open down. So is this a maximum or a minimum value? Well, it's at the top of my parabola, so it's a maximum value. What is that maximum value? Y equals 8. My roots we already got from root form. So x equals 2 and x equals negative 2. And here it kind of turns out nicely that my y-intercept is actually my vertex. The vertex is on the y-axis, so my y-intercept is 0, 8. It might do me some good when I'm graphing to find some more points. So I have an x value, I have the point where x is 0, I have the point where x is negative 2 and positive 2. Maybe it would be good to find the negative 1 and positive 1. Maybe it would be good to find when x is negative 3 and positive 3. That might be good too, because those are the next points out. So remember to substitute your x values into the formula, into the function, and find your y values. So go ahead and pause your video and try to find the corresponding y values and plot those 4 points. So I have corresponding y values for negative 1 and 1. I have them as 6. So I plotted those points here, and that fits nicely with what I have on my graph already. And then if I substitute negative 3 and 3 into my equations, I end up with negative 10 both times. So that ends up down here, which also fits nicely with the points I have. So I'm going to go ahead and draw in my parabola. It's a little wobbly, but that's okay. I'm going to highlight my axis of symmetry. Now on the left side of my graph, from the left to the right, I notice that my parabola is going up like that. So it's increasing. And then once it hits the vertex, from left to right, it's decreasing. So it's going down. So that's going to help me out in a moment. My domain is all real numbers. My range comes from the maximum value. That maximum value was y equals 8. And since it was a maximum, that means that the rest of my graph is everything under the 8 and equal to the 8. So my range is all the y values less than or equal to 8. Everything below that maximum value. The increasing interval of the graph is right here. So it's everything that's to the left of 0 or less than 0. So increasing is all the x values that are less than 0. The decreasing portion of the graph is all of the x values that are to the right of 0. So everything that is greater than 0. So x is greater than 0.